Okay, Dragan, we're ready, and I'm going to put this.
Okay, well, welcome everybody to our Biostatistics webinar for 6125 and 8125. My name is Dragan Skorpanik, and I'll start the presentation here. The things that we will address today, this is on slide 2. We'll talk about the concepts and interpretation, the odds ratio and risk ratios, 2x2 contingency table, graphs, independent and dependent two-sample tests for mean difference, one-way ANOVA, p-values in general, cumulative incidence, incidence density, prevalence, success in the course, quizzes and tests, and at the end, questions and answers. Okay, we're moving to slide 3. Interpretation, remember that in all of your assignments, interpretation is very important, not just the outputs from the SPSS. Closely follow the step-by-step guides that are available to you every week. They do provide a good model for what you should report in your interpretations for the applications. Include analysis and explanation of the data sample. Explain what is typical and how much deviation from the norm or from what is hypothesized did you observe. How widely the data vary in measurement, how are the data distributed in relation to the variables being measured, and have you found a statistically significant relationship? So we'll talk a little bit more about this in a few minutes. Okay, slide 4. We'll start with the odds ratio. Remember that's the odds of exposure in the disease group divided by the odds of exposure in the non-disease group. It's usually abbreviated by OR. The risk ratio is the ratio of the risk in the exposed group to the risk in the unexposed group. We usually abbreviate that as RR. Both are based on the calculations of the numbers available in our standard 2x2 tables. Okay, slide 5. 2x2 contingency table, you've seen those in your applications and in your step-by-step guides. We have cases and controls that's one of your variables. The other variable is the exposure, exposed and not exposed. We usually use the generalized setting A, B, C, and D. A is the number of cases that were exposed. B is the number of controls that are exposed. C is the number of cases that are not exposed. And D is the number of controls not exposed. So basically, column 1 is the data for group 1. Column 2 is the data from group 2 cases and controls. Row 1 are the positive outcomes exposed, and row 2 is the negative outcomes. Each row and column is added, and these are used in many applications in both prospective and retrospective studies. Okay, slide 6. Odds ratio, again, it's the odds for observing the outcome in the exposed group divided by the odds for observing the outcome in the unexposed group. The simplified calculation for that, if you remember, is A times B divided by B times C, which of course multiplies the numbers in the 2x2 table. The risk ratio is the risk in the exposed group divided by the risk in the unexposed group. And the first risk is A divided by A plus B. And the second risk in the denominator is C divided by C plus D. These numbers do make a lot of sense if you look back at the 2x2 table on slide 5. The odds ratio is used in both retrospective and prospective studies, but the risk ratio, remember, is used only in prospective studies because the calculations here are based on the incidence. Okay, we're ready for slide 7. Okay, in slide 7, we are looking at the calculation for the confidence interval. Many of you probably remember this. This was a few weeks ago when you had to calculate the confidence interval. This will show up again on the final exam, so it's really important to kind of keep this these formulas handy. Remember what happened here. We have to use logarithmic transformation of the odds ratio to get the normal distribution. So the step one is to calculate the standard error for the logarithm of the odds ratio, which is the square root of the reciprocals of the counts that you have in the 2x2 table. Step two is you need to calculate the 95% confidence interval for the logarithm of the odds ratio. You take the logarithm of the odds ratio and add and subtract 1.96 times the standard error. Step three, you need to go back to the original units. So the 95% confidence interval for the odds ratio will be e raised to power whatever you calculated earlier. There will be two numbers, so you're going to get two limits. Remember that you need to look for the value 1 to see if it is included in this confidence interval. 1 is the critical value here because remember what a odds ratio is. It's the ratio of two numbers. So if that ratio is equal to 1, then there is no difference between the odds in the exposed group and odds in the unexposed group. Okay, slide 8. If the odds ratio is 1, or if the risk ratio is 1, conclude that there is no association between exposure and the outcome, whatever that may be. If a confidence interval for the difference between two means or proportions includes 0, conclude that it is plausible that the difference is not statistically significant. In this case, the associated p-value will be greater than 0.05, and the null hypothesis is not rejected. But remember that failure to reject the null hypothesis does not necessarily mean that the null hypothesis is true. One can never prove whether the null hypothesis is true or not. You can only have evidence in support of it or against it based on the p-value and the confidence intervals. Okay, Pat, am I done with this part, or should I keep going?
Okay, thanks, Dragan. So
okay.
Now we're going to talk a little bit about graphs, about how to, actually I'm going to go into SPSS and actually run some graphs because, I think that, the best way to get comfortable with SPSS and the best way to get comfortable with doing statistics is to get in and practice and just try to get more comfortable with the tools. So we're going to do a scatter plot. Scatter plot is the relationship between two factors. It'll give you a trend line, which can be positive, it can be negative, or there can be no correlation at all. We'll also look at a box plot. It'd be basically a side-by-side comparison of some data sets. Back in week 2, there was an emphasis on graphs, and there was a PowerPoint that went through graphs. There's a histogram. It'll display continuous data in columns, measures such as time, temperature, and age, as well as bar graphs that display data in separate columns arranged by different ways to group. Okay, so hopefully all of you are familiar with SPSS. And you're getting used to running output in here. I have some data sets already open here for us. So again, even if, statistics is not your thing, one good survival skill in this course is just to get as comfortable as you can with the tool itself. So the way you're going to run graphs most of the time in SPSS is you're going to open your data set. Once you have that data set, you're going to go to graphs. You're going to go to legacy dialogues, and then you're going to select the type of graph that you're looking for. In most cases in this course, you're going to be doing simple, like a simple scatter. And you have your variables over here on the left, and you just select. You can click and drag into the X and the Y axis. In most cases, you have additional options over on the right, which you can use. And once you have your graph set up, then you're going to click OK. And it's going to go back to our output, and it'll produce this graph. These are all, I already have these kind of preloaded. They're from the step-by-step guides. Again, a good way to practice, especially getting ready for the final exam is to go back and go through all of your step-by-step guides. They're very helpful for your weekly applications. They'll also come in very, very handy and helpful in preparation for the final exam, which is not too far off. Okay, so going back to my data set, we also had a box plot. We'll do a simple. We have age and income. As you can see here, we've got several different groupings here for this variable. You can do a histogram. We're just going to do a histogram of age. This is one variable. You select a variable. If you notice here, I already have these preloaded. Okay, but if you all you do is you select your variable and you can click the arrow, or you can literally just click and drag. You click OK, and we have this histogram. This is the same histogram that is shown in your step-by-step guide, I believe in week 2. And then finally, we have, from the same data set, we have a bar graph. Same way. You select your variable, click OK, and now we have a graph here of a bar graph by income categories in this data set. Going to move on to 2 different types of t-tests. We have an independent sample hypothesis test. Remember, you have a null hypothesis, as Dragan mentioned. The null hypothesis is that there is no difference between the 2 population means. So you're always going to start out with a null hypothesis, and as Dragan mentioned, you're not going to prove or disprove. You're not proving the alternative. You're not. So anyway, so the null hypothesis, there's no difference between the 2 means. The alternative hypothesis is that there is a difference between the 2 means, that it's significant. The main assumptions with this is that they're independently selected. For example, the selection of the first sample does not affect the selection of the second sample. And the associated confidence interval, so another way to check for significance is if 0 is included in the confidence interval. So if the confidence interval is from -5 to 8, then it's going through 0, okay, and so it would not be significant. If it was not going through 0, if it was going from +5 to +8, for example, then it would be statistically significant. The next one is a dependent 2-sample hypothesis test. Again, the null is that there's no significant difference between the 2 means. The alternative, the 2 means are statistically significant. The major assumptions, you have samples that are dependent, such as a before and after, and the same holds true with the confidence interval. So I'm going to go back to SPSS. I'm going to go back to 2 data sets that I have loaded here for you. So as you can see in the histidine.sav data set, okay, when we're doing t-tests, you're going to go analyze, compare means, and when we're doing an independent t-test, you're going to select, and I selected, I'm going to go back here. Okay, so you select your variable. You also select your grouping variable. You're also going to need to define your groups. So if you notice here, your groups are 1s and 2s. So when you define, you have group 1 and group 2. And we're going to have, we have our independent samples t-test here. And you'll notice the significance, the p-value is less than 0.05, and the confidence intervals do not include 0. So we would conclude that this is a significant difference between the two means. Going back here to the ones and twos, if you notice it converted it to men and women. How did it know to do that? If you recall, there's two tabs in SPSS. There's the data view and the variable view. And in the values, here in the variable view, it was defined 1 equals men and 2 equals women. That's how that happened. Finally, we have a one-way analysis of variance. It's a generalization of the independent two-sample hypothesis test. Can be used when comparing more than two groups. So you can't use a t-test when you have more than two groups in your sample, in your study. So the null hypothesis is there's no difference between the means, the alternative. The null is false. For example, at least one of the means is different. The initial ANOVA is not going to tell you where that difference was. It's only going to tell you that there was a difference. You're going to have to do some post hoc tests to determine that. So assumptions, number one is we have independent samples, normally distributed populations, and homogeneity of variance. A non-parametric alternative is the Kruskal-Wallis test. So here we have a sample. We're going to go compare means. We're going to do a one-way ANOVA. We have our two variables. A couple of other options over here to look at. First of all, we have post hoc tests. So in the weekly assignment, it has for the LSD and the Bonferroni. You just simply select those. You can also select other post hoc tests of your choosing. Notice too, on all of these, you can also select your significance level. It's kind of defaulted, and we typically use 0.05 as our significance level. Also, if you select options, that's where it gives us the homogeneity of variance test. Click. Go back here, click OK. And we have our one-way analysis of variance. And the significance on the homogeneity of variance is not less than 0.05, so we can move forward with this test. The significance is less than 0.05, and then that's between all of the groups. So then the post hoc, we have the LSD on top and the Bonferroni on the bottom. And what this is going to do is it's going to look for where those differences were. Because some of these groups will have significance. So here, the 0.026. But some other examples, we don't have it. It's not less than 0.05. Finally, we're going to the p-value. It's also referred to as the observed significance level. If the p-value is less than 0.001, the results are considered highly significant. If it's between 0.001 and 0.01, the results are very significant. If it's between 0.01 and 0.05, the results are significant. If it's greater than 0.05, the results are not statistically significant. And if it's between 0.05 and 0.10, there is a trend towards statistical significance that can be noted if appropriate. Okay, now we're going to move to confidence cumulative incidence, and I believe Kelly is going to take it from here. I'm going to have to unmute her, so give me a moment here, Kelly, before we start. I've unmuted everybody. And Kelly, give me 1 second to mute you.
Okay.
Okay, Kelly, you're on.
Okay. So let us start out by, can you, do I?
Say again, Kelly?
Can you hear me? Patrick?
Yes.
Okay, can you hear me now?
Yes.
Okay, can you give me control
Yes.
or no?
I just gave you
Okay,
control.
here we go. All right. So here, like Patrick said, we're going to talk about cumulative incidence, prevalence, and incidence density. Okay. Now on this first slide, and for some reason my screen is frozen. Give me just a second. I've been having problems ever since it was time for us to get started.
Okay, it looks like you're up.
Can you see my my screen? Okay, great. Okay, so for cumulative incidence is the total number of new disease or injury cases during a specific amount of time. I'm going to start with prevalence actually, because I want to show you all something. So looking at prevalence, that's the number of persons in a defined population with a specified disease or injury or whatever that variable may be that you're looking at. When you look at incidence density, you're looking at you're adding time to the equation now. So what you'll see, it's freezing up on me again, Patrick. I may have to let you
Do you want me to take control and you just tell me to advance the slides?
Right, thanks.
Okay.
Okay. So back to the prevalence. Okay, so again, you're looking at the number of people with the disease or trait or whatever the specific variable is divided by the total number of people in that population. So for example, in a population of 100 people that are smokers, if 10 of them develop lung cancer, then you would have those 10 cases of lung cancer divided by 100 people in your population, which would give you 10% prevalence. And again, some people get prevalence and risk confused. When you're looking at prevalence, you're looking at existing disease occurrence. And when you're looking at risk, shows a possible occurrence of a new disease. So at any given time, it's the number of people at that time with that specific occurrence, so whether it's cancer or whatever the disease may be. Okay, if you'll go on to cumulative incidence.
I have an issue with incidence density.
I'm going to go over incidence density. I just hadn't gotten to it yet. So for cumulative incidence, again, you're looking at the number of new cases of a disease divided by the total number of people at risk. And so when you're looking at incidence, you're looking beyond what has already occurred, per se. You're looking at new occurrences. And so and you want to put emphasis on risk. So in prevalence, like I said, you're looking at the total population, and now you're only looking at who's at risk in this population. So if a person has already been diagnosed with the disease, they're no longer at risk to have the disease. They actually have the disease. So let's go back and, for example, look at the occurrence of 100 people in your study, and 10 had lung cancer. So say over the first year, 100 people, for the first year, 100 people you were observing were at risk, and by the end of the year, you only had 10 who developed lung cancer, then your cumulative incidence would be 10 divided by 100, which is still the same 10% that you had prevalent. But say in the second year of your study, you had 10 more people. In year 2, again, you no longer have 100 people who were at risk. In year 1, 10 people developed lung cancer. So now year 2, there are only 90. So again, year 1, you divide 10 people who developed lung cancer by the total population, which was 100. Now in year 2, you're dividing those 10 new people who developed lung cancer by 90. 90 because you took subtract the 10. And so 10 divided by 90, you would get 11% for your cumulative incidence for year 2. And you would continue like this until the end of your study. So for the year, you actually have 80 people at risk for the third year. It's 20 people with lung cancer in the first 2 years. And assuming that all of the people in your study are still being observed. So you may have had people who may have dropped out of your study. And so if so, then you wouldn't have 80 people at risk that second year. You'd have however many people were still in the study in that second year, whether they dropped out or developed lung cancer. So now we can move on to incidence density. And I think someone said they had questions. If you could just type that in, I'll try to answer it when I'm going through incidence density.
Mm-hmm.
Okay, so incidence, frequency of new occurrences during a study period of time. The incidence rate is the number of cases over a defined period of study. And so the denominator is now person time. Okay, and so person time years would actually be the people at risk times the time they were at risk. And so it's getting a little deeper now than just cumulative incidence. You're being a little more thorough with your study now, because you could have had all 10 of those people diagnosed with lung cancer diagnosed at the same time, but that's not very likely. They may have been diagnosed with lung cancer at different times throughout the year. And so now you're looking at exactly how much time of that year they contributed to actually being observed for lung cancer. Now, so if you look back at that, the first year that of your study, all of those, like I said, all of those people weren't diagnosed with lung cancer on the same day. Although it may have been possible, but for sake of this example, it didn't happen that way. So after the end of 3 months, say you checked your participants in your study every 3 months. And so at the end of the first 3 months, which would be a quarter of a year, you would see how many were diagnosed that quarter and multiply it by 0.25. So 0.25 being a quarter of the year. And then that second quarter of the year, so say by June, you want to see how many people develop lung cancer from June to April to June, which would be the second quarter of the year, you would say they contributed half the year, and so on with the third quarter. And I had a document showing actually what I'm talking about, but actually, Patrick, since that's not part of this, the PowerPoint, maybe it will actually come up. Will you see if you can get it to give me control again so I can show this?
Yeah.
This slide, what I'm talking about.
My screen
Okay.
is blurring.
So say here with the lung cancer, in this table here, say those 10 people that developed lung cancer, 2 of them developed lung cancer during the first quarter. And you're the researcher, so, I mean, you can make the time whatever you want, you know, the time to be for your study. But for this sake, we're saying that you check your patients were diagnosed every quarter, at the end of every quarter. Okay, so I think that someone was asking what is the time allotment. I'm not sure if that's what you meant by it, but the researcher just sets whatever time they so choose to set. And this is similar to what's in your step-by-step guide for week 3, but it just has a little more detail. And so I'll post it in my classroom and email it to Dragan and Patrick to post in their classroom. It has a little more detail of how those numbers came about in the table. But again, again, if you say that you had 100 people diagnosed with cancer, and again, for incidence density, you want to look at exactly how much time each of those people contributed to the study. And so if you had 2 diagnosed the first quarter, you would multiply 2 by that first quarter, which would be 0.25, and you would get a half of a year, 0.5. And that's the first row of the column. On the second row, you see the second quarter, and we'll say that 6 people were diagnosed in that second quarter. And since they were diagnosed in the second quarter, they made it through half of the year before they were diagnosed. And so you multiply that 6 by 0.50, which is half the year, and you get that they contributed 3 person years. And again, person years is simply the people at risk by the time they were actually at risk. And then you say that 2 more people were diagnosed in the third quarter, and that 2 times, and since they made it through 3 quarters of the year, that's 0.75. And so you would multiply that by 0.75 and get that they contributed 1.5 person years. This bottom column is just the total. So you see 10 for the number of people diagnosed that full year, and 5 for the number of people, the total number of person years that those 10 people contributed. And so 90 people were left out of those 10 people who were diagnosed. And so those 90 people contribute a full year to the study. And so you would take that 90 person years and add it to the 5 person years that the 10 people who were diagnosed contributed, and that would give you 95 person years for year 1. Do you get what? I hope I'm not confusing anybody.
I'm a little bit confused. Like, I never really got this table. I never really got this table to begin with.
I'm sorry. I'm sorry. I couldn't hear you.
No, I was saying, this is Kimberly Gordon. I'm sorry. I was saying that I never really got this table, and if you can repeat it, that would be great.
Sure, sure. And again, it's just like in the step-by-step guide. But I think in the step-by-step guide for this week, which would have been week 3, some of how those numbers came about was left out of the guide. Or some people may not have understood where those numbers came from. So I just took a different, just created another guide that I use in the course that I am in, and so I just was sharing it now with everyone. And so it is still the same concept in your step-by-step guide from week 3, but I'll slow down and go over it again. So if you have 100 people you're studying,
Right.
and at the end of the first year of your study, 10 people in your study were diagnosed with cancer.
Right, which is 2 in the first quarter, 6 in the second, and 2 in the third.
It's what?
No, I was trying to follow the numbers. It's 2 people in the first quarter. 2 people in the first quarter. Right. That's how you got the 10.
Yes, so 2 people were diagnosed in the first quarter, 6 in the second quarter, and 2 in the third quarter. And so that was a total of 10 people diagnosed the full year. So what happens is, during that last 3 months of the year, if no one was, and say the researcher was diagnosing or testing the patients at the very end of the year, well, this patient may have been diagnosed, say, December 31st, but they've made it through the full year. So that's why you don't see a fourth quarter in the table, because the researcher is testing the participants at the end of the year. And so those people that may have been tested on the last day of the year, they actually, although they may have been diagnosed with lung cancer, they still made it through the study the full year. So they've contributed a full year to the study, a full person year.
Right. And how you got the 90 was, though, it's the 100 people who contributed. It's the 100 total minus the 10 who were diagnosed. That's how you got the 90.
Correct. So you have 90 people who made it through the full year without being diagnosed. And so you would take that 90 person years, because 90 people contribute a full year, and you would add that 90 to the 5 total person years from your table that the 10 people contributed, because those 10 people did not contribute 10 person years because they did not make it to the end of the year.
Right.
Do you get it now?
Yes, I got up to that part. Now, where it says ID, the ID equals new cases, incident density equals new cases, number of people divided by the number of people at risk times they were times the time that they were observed. So this would be, the number of new cases would be the 10, right? Because of the 10 people who were diagnosed.
Got it. Yes.
Right. And the number of people at risk. How do I accumulate that?
So what you're looking at is the number of people at risk, which are the 90. This is not just 90 number of people at risk. This maybe, let's say this is in parentheses.
Hello?
So what the denominator is person years. Okay? The denominator of the equation is person years. And person years is the number of people at risk time multiplied by the time they were observed.
Okay.
So you're getting person years by doing this table here is giving you the answer to the bottom, to the denominator of that equation. And I think in the quiz, I had several people ask me about this in the quiz because they, I guess, weren't sure of how, the denominator was coming about. Because now in incidence density, you're on. Right. And in incidence density, you're only looking at the number of people at risk times multiplied by the time they were observed. In cumulative incidence, you're looking at the number of cases divided by the total people at risk. You're not looking at the amount of time they spent in the study before they developed the disease. So that's the difference between cumulative incidence and prevalence, where you're just looking at, in those instances, you're just looking at dividing it by the number of people at risk or by the number of people in the study. So now with incidence density, you're actually looking at how much time each of those people contributed.
Okay.
So it's actually a lot more incidence density gives you a, what's the word I'm looking for? Help me out, Dragon or Patrick. It's compared to looking at only the prevalence or only the cumulative incidence. Incidence density is a more accurate look at what actually happens in your research, because it's delving in deeper, because it's taking into account the amount of time a person spent in the in the study. Does that make sense?
A little. Now, a question I had, and I'm glad that we're reviewing this. On one of the quiz, I had a question where, like, say for example, the middle where it says the multiplier based times, those were missing. How do you go about finding what those what this is supposed to be?
Okay, so your multiplier, again, is the amount of time that person spent that year before they were diagnosed. And so, again, the first quarter of the year is 25% of the year. So that's where the 0.25 comes from. In the second quarter, those people have spent half the year in the study. And so half of 1 is 0.50. And so 0.50 would be the multiplier for the second quarter. And third quarter, they spent 3/4 of the year, or 75% of the time, 75% of the year in the study before they were diagnosed. And so that's where the 0.75 comes from.
Okay.
Does that make sense?
Kind of.
Does Dragon or Patrick have something that could?
Yeah, I mean, you know, this is kind of confusing and can be kind of a mind bender. You just have to, sometimes you just kind of have to take it row by row and column by column, and you know, make it real with, okay, I have 100 people, and you know, 10 of them, you know, lost 10 in the first quarter. A quarter is 0.25, and so just try to figure out, okay, I got a column figured out, now I've got my row figured out, and then just go to the next column and the next row. Because if you look at it overall, I mean, even for us, sometimes you have to scratch your head and try to figure it out. But if you just try to simplify it in each column and each row, eventually it starts to make sense. Trust me.
Okay. All right.
And no, it's okay. We want you to understand it. And then when in incidence density, again, you need to remember that's just the first year. So then when you start looking at the second year, you have to remember that, again, when you're looking at the person years, you have to subtract all of the people that either dropped out of the study or who were diagnosed with the disease or whatever their occurrence was. You have to subtract them out of your denominator. When you get ready to come up with your denominator, you need to subtract them from the total population. And so in this example in year 2, it says you'd had 20 people who were diagnosed or dropped out. And so if you only had 90 people at the beginning of the year, and now by the end of the year you have 20 people diagnosed or who dropped out of the study. So now you're only left with 70 people to contribute a full year, a full person year.
Okay.
And so you would add 70. Now the first year you added 90 to whatever the total was, the person years was in your table. But now in the second year, now you're adding 70 to the total person years in your table there. So it's 79 total person years for the second year. And then if there was a third year, you would do the same thing.
Okay.
So you keep having to subtract those people that were either diagnosed or dropped out in the previous year. You don't keep adding them into you don't leave them in the contributing to the person years, because these people aren't at risk anymore. They've already contracted the disease or whatever the occurrence was. They've already done it. So they're not at risk. They already have it. So that's why you have to keep subtracting them from your total population at risk. Does that make sense?
Yeah. I'm trying to follow, but this was one of my biggest issue on the test. Like I couldn't figure out how to work this problem out, and I'm still trying to figure it out. But I don't want to keep the rest of the class, so you can go ahead. That's fine.
Well, you can, if you would, you can go ahead and schedule an appointment on the with one of us, and we can just continue to go over it further with you one-on-one.
No problem.
I think you're in my course, so just let me know when you're available, and we can do some one-on-one time.
Okay, no problem.
Did anyone else have a question about that?
I think everybody else was muted, so.
Okay, I don't think anyone typed in a question.
No.
Okay. Okay, so I'll go ahead and go through the next slides here real quick. Class success. Are you all seeing my screen? I want to make sure that this PowerPoint is showing up. Okay.
Yeah.
So every week you want to make sure that you're looking at whatever the resources are for that week, and definitely reading all of them. If you just read one of the resources, you may have some knowledge, but when you put all of those resources together, then you're able to more firmly grasp the concept. So I would really suggest that you take the time to read all of the resources, including the step-by-step guide, to put all of it together so you'll get the full picture. If you're just reading the step-by-step guide, you're not getting the full picture. And also the text. Another thing is to seek help from us, because that's what we're here from, Dragon, Patrick, and myself. You can ask questions in the study group area, which many of you already do. But we also have the email, which is statsupport@waldenu.edu. That's STATSUPPORT. statsupport@waldenu.edu. And so you can also go there to email a question if you're checking your email more often than you're going in the classroom. And also, again, making appointments. And we're here to help you as much as we can. And as far as using SPSS, I always like to tell that there's so much information online. When I first started using SPSS, we didn't have peer mentors. And I used YouTube to learn how to use SPSS. Just to be completely honest, there were so many videos of showing you how to use SPSS. That's actually what I did. But you do have to be careful about some of the jargon they use, because they may use different wording than what we're using here at Walden in your application assignment. So you don't want to confuse yourself. But at the same time, that's a place you can go to actually see a video of the analysis being done. Especially after this course is over and you go into statistics and other courses that may not have peer mentors available. Okay, the quiz information. Was there a week 3 document on the quiz? Did you? I don't know if I have that. Dragon.
What is the quiz document for week 3?
Yeah, that's I don't know where that came from.
I never heard of that.
I don't know either. This may have been from last. Was this the slides from last quarter?
You know, these slides from several quarters back, they've just continued on, so there may have been a quiz before.
Probably step-by-step guide.
Yeah, the step-by-step guide, I would assume. But again, you want to make sure before you take the quiz, you're practicing going through the step-by-step guide. A lot of times reading your text before you take the quiz, because the information on the quiz is coming from your text and other resources you have, and not just the step-by-step guide. And you can request to retake the quizzes. You have to request to retake the quiz at a certain time.
Okay, well, I don't think we have any more quizzes coming on.
Yeah, I think the last quiz was actually this week.
Yeah.
Yeah, so we'll go ahead to the next. And here's some other resources that you can use. Yeah, davidmlane.com, that is another resource I use, especially when I was first starting to taking biostatistics myself several years ago. Here's that email address for stat support. And again, the PowerPoint will be in your classroom, so if you can't jot all this quiz. Okay. So for your week 11 quiz, if you need to retake the quiz, you need to know that you have to request to retake it early enough. You don't want to wait and take the quiz on the last day of the week, because you won't have time to request from your professor to let you retake your quiz.
Okay.
Thanks, Anika. I wasn't sure about that. Again, mentor appointments, and that's through WC Online. The actual login for that, I don't have it memorized, but I'll type it in there. I'll pull it up on my computer and type it in for you, just a second. Okay, it's waldenu.mywconline.com, and I am typing that in the chat area. Okay.
What is that for? I missed that.
That is if you want to make a one-on-one appointment with your peer mentor. Or say the peer mentor for your class isn't available at the times that you're available, then you can just request an appointment with any of the other peer mentors, but make sure you're requesting an appointment with the peer mentor that's in your section of the, in your course. Because when you go into WC Online, you'll see a list of peer mentors, and under their name, you'll see the course that they're peer mentoring for. And so make sure you're choosing one of the peer mentors that's for your course. And again, that's at the WaldenU.my.wc online that I copied into the chat area. Person time. Here's a nice little link to what I am believing. I have not even looked at this link, but evidently it's some more information about person time there.
Wow.
Okay. Anika, one thing you can do if there's not a time that you could chat with someone, just email us back and forth. It may be a lot quicker than checking the classroom. So if you'll just email someone, and like, I guess that may have been Patrick, just told you to contact him in Blackboard. So yeah, if you can email him your question, and I'm sure he'll email you as soon as he probably checks his email more often than he checks them. I don't know. Myself, I check my email more often than I go into the classroom. So I would see a question in my email before I would see it in the classroom.
Annika, I check the Blackboard several times a day, so you can use that. Or you can email me directly.
Okay.
Was that Patrick?
Yes.
Okay.
Okay. Are there any more questions?
You know, I'm going to, and before I unmute everybody, I also want to let you know we have been recording this. So I'm going to have to download the recording. So that takes a little bit, but probably by tomorrow, I'll be able to send out a link. I'll send to Kelly and Dragon, and then we can post it into your courses so that you can review this at a later date. So with that, I'm going to unmute everybody. We may have more feedback, but if anybody has a question,
hi, this is Audrey. I have a question. I'm sorry I just clicked on. I just got off work. So I'm just recorded, so I'll be able to hear at a later time?
Yes, this is recorded, so I will post this in the courses. And actually, we've recorded some webinars before in other courses. I'll go ahead and post all of them. It's over a very similar topic.
Okay, thank you. Sorry to have missed it.
Oh.
Any other questions? Any other questions?
What about are we getting anything?
I didn't catch that. Either say it again or type it to the chat.
Okay. I'm going to type it.
Does anybody else have questions? Okay, well, I can go ahead and wrap up. Like I say, we'll be posting the recording, but also encourage you to reach out directly to your peer mentor, and especially as we get closer to the end of the course and as the final exam gets closer, especially to reduce anxiety and be as prepared as possible for that experience. All right, well, thank everybody for taking time on a Friday evening.
Thank you.
Okay, thank you.